In this session, we will solve questions from past papers based on trigonometry, sine and cosine rules and bearings. Please share and subscribe.
Hello and welcome to another session of trigonometry. So in this session, we will cover a few questions from the past paper. If you'll see 0580 41 October November 19, and we also covered from the October November or May June. So let's start with this question, and concept wise I already uploaded a couple of videos related to the trigonometry. Please go through those videos. In case of any issues or if you have any doubt, please do comment in the comment section. I will create another videos on those. Okay, so let's start with this question. This is question number 5 from 0580 41 October November 19. So in this, if you'll see, the diagram shows a triangular field ABC on a horizontal ground. Olaf run from A to B and the distance between A to B is 120 at the speed of 4 meter per second. Then from B to C, which is 180 meter and the speed is 3 meter per second. He then run at a constant speed from C to A and the distance between C to A is 150. And the question is, his average speed for whole journey is going to be 3.6 meter. We have to identify the speed when he run from C to A. So this is nothing related to the first question, is nothing related to any trigonometry. It's simple speed and distance. So average speed, when we say, right, average speed. Okay, so average speed is always going to be total distance upon total time. Okay, and speed is going to be distance upon time. So there are the two things which we need to remember. Speed is going to be distance upon time and average speed is going to be total distance upon total time. Now use this concept in order to solve this question. Okay, so if you'll see here, distance between A and B is 120 meter and the speed is also given, which is 4 meter. So time is equals to distance upon speed. So time is t1 from A to B. So t1 is going to be distance is 120 and speed, if you'll see, 4 meter. I will divide this one. This is going to be 30. So t1 is equals to 30 second. Okay, so we got the time which was between A to B. Now again similarly B to C. If you see B to C, time is equals to t2, which is distance 180 upon speed. In this case it is 3, so 60 seconds. Okay, now we have time for t2 as well. Now t3 is going to be distance, which is 150, and upon speed we don't know. I am going to write here x, so x meter per second. This is our time t3. Okay, and t3 is not, we are not sure about is the value of t3, right? So I'm just going to write it like this, 150 upon x, where x is the speed when he run from C to A. Now average speed, I am coming to this one. Average speed is equals to total distance. What is the total distance? So we know 120 plus 150 plus 180, right? 120, 150, 180, or 120, 180, 150, that is upon total time. Total time is nothing but t1 plus t2 plus t3, right? Average speed is already given in the question, which is 3.6. So I am going to write here 3.6, and if I will add all this, I will get 450. Okay, t1 30 plus 60 plus t3, I am going to write as it is t3. So t3, my bad. So here, like when we do cross multiplication, there is 1. So I can write here 90, because 60 plus 30 is 90, plus t3 is going to be 450 divided by 3.6. Now 450 divided by 3.6 is going to be 125. So t3 is equals to 125 minus 90, which is going to be 35. Okay, so now 35 is the second. 35 seconds he took. So we have like T3, we have X. X is equals to, it's going to be X is equals to 150 divided by T3, right? Because here when we exchange the value of T3 and X, it will cross multiply. So 150 divided by 35, if I will divide, I will get 4.29 meter per second. So 4.29 meter per second is the answer, or is the speed when he runs from C to A. So like this way we can identify the value. Okay. Now moving to next. Now if you see, use cosine rule to identify the value of or angle of BAC. Okay. So if you go back to previous question, this is our question. BAC, that means this angle. This angle, right? So this angle, that means it is going, A is 180, B is 120 and 150. Okay. So I am going to write here what is A, what is B and what is C. Right. So A is 180 as per previous question, B is 150 and C is 120. We have all the value, we have to identify the angle. So cos A is equals to, I am directly writing here, B square plus C square minus A square upon 2BC. This is the formula, right? Cosine rule. Use cosine rule and find out. So B is, we have 150 square plus 120 square minus 180 square upon 2 into 150 into 120. So cos theta is going to be 4500 if I will solve all this, and upon 36,000. Then theta is going to be cos inverse of 0.125, which is going to be 82.8. So angle ABAC is equals to 82.8 degree. So this is our answer. Okay. Now the bearing of bearing of C from A is 210. Okay. Let me redraw for you. This was our question, right? If you'll see here, this is, I'm just A, this was C, and this was what? B. Okay. Now the bearing of C, that means the direction of C from A. Direction of C from A. Whenever we say these things, right? Bearing of C from A or bearing of A, that means the direction of that point with respect to A. Okay. So whenever we measure the direction, we have to measure in a clockwise direction. Okay. So now for this question, if you'll see the bearing of C, that means the direction of C from A, that means this is our 210. Okay. This angle is given 210. And if we'll remember, we identified this angle, which was 82.8. Okay. So we have this angle. Okay. So we can identify this angle, right? So this angle is going to be 210 minus 82.8, which is going to be 127.2. Now coming to the question, the bearing of B from A, that means the direction of B, right, from A, that means at A we have to draw north, and from A to B, this is our requirement, which we already calculated, 127.2. Another question is, find the bearing of A, that means the direction of A from B, that means this is going to be our requirement, right? So total angle is 360. If we can identify this angle, then we can find out, right? So if you'll see, let me redraw the diagram. This is B, this is A. Okay. This angle we have already calculated, which is 127.2. This angle we don't know, both are north, that means both are parallel to each other. If I am writing X here, these are the co-interior angle, So co-interior angle properties, sum of these two angle is always supplementary. So x plus 127.2 is equals to be 180 degree. So x is going to be 180 minus 127.2, which is going to be, if I subtract it, 52.8. So this is nothing but x, right? This angle we calculated. So this angle, if I'll subtract from 360, then we can get the answer of bearing of A from B, which is going to be 360 minus 52.8 if I subtract 307.2. So this is the bearing of A from B. Now the question is, D is the point on AC that is nearest to B. Okay, so D is the point on AC. Okay, so suppose like consider this one only, this diagram. I'm just redrawing that. Okay, A, this is what C, this is B, and suppose there is a D. So D is the point on AC which is nearest to B. Whenever it is nearest to B, any point which is nearest to B, that means it is always going to be perpendicular. Okay, so that means this is going to be perpendicular. This is already given 120. If you'll see the previous diagram, 120 is given, right? And there is somewhere D like this. So this is 90 degree. Okay, so coming to question, this angle we know, which we already calculated, 82.8 in the first part. Now this is the right angle triangle. This 120 degree, sorry, 120 is the length, opposite to 90 degree, that means this is going to be hypotenuse. We have to identify this one. This is going to be adjacent. Adjacent and hypotenuse is ka. So cos theta we have to use here. So cos theta is equals to AD upon adjacent upon hypotenuse, which is going to be 120. So AD is equals to cos 82.8 into 120. If I will solve it, AD is going to be 14.9, or we can write 15 meter. So this is the distance D from A. Okay, so like this way, whenever they say like perpendicular, that means, sorry, shortest distance or nearest, that means we have to take the shortest distance which is perpendicular. Okay, moving to the next question. If you'll see this question, the diagram shows a field ABCD on a horizontal ground. There is a vertical post at C. Okay, vertical post at C, and angle of elevation of the top of the post is like, suppose this is C. Okay, top, this is post, and from B the angle of elevation, this is B. So angle of elevation is 19 degree, my bad. Distance is 107. If you see between B and C, the distance is 107. Question is, find the height of the pole. This one. So again, if you'll see, this is what adjacent to the angle is adjacent. This is opposite to the angle. This is going to be 90 degree. Opposite to the angle is always going to be opposite. So opposite and adjacent, tan, right? TOA, tan. So tan 19 is equals to opposite, that means height of the post, I am going to write here h upon 107. So height of the post is equals to 107 into tan 19. So if I will solve it, I will get 36.8 meter. So height of the post in this case is going to be 36.8 meter. Now use the cosine rule to find the angle BAC. Angle BAC, this angle we have to find out. So again, if you'll see, three sides are given, one angle we need to identify. So how we can use this one? So simple rule, 107 square, formula is like A square is equals to B square plus C square minus 2BC cos A. Cos A we have to identify. 107 square is equals to 158 plus 132 square minus 2 into 158 into 132 cos A. Okay, So cos A is going to be 30,939 upon 41,712. If I will solve it, A is going to be 42.26. So angle is 42.26. So like this way we can solve the question. So these were the questions from the past paper. If you have any other questions, please add the comment in the comment section. Thank you for watching.